Hi everyone. In this session, we're going to review a homemade oscilloscope built around the STM32F401 microcontroller. For the development, we'll be using a lab breadboard that includes a signal generator, which will be very useful for our purposes. The generator can produce square, triangular, or sine wave signals, and its amplitude is adjusted through a potentiometer. Next, the signal passes through an adapter circuit that adapts the voltage range to match the microcontroller's requirements. In addition, the circuit includes protection LEDs to prevent overvoltage situations. Finally, the signal is fed into one of the microcontroller's ADC inputs, where samples are taken for signals up to 20 kHz. Higher frequencies are not well supported at this stage, since the goal is to work mainly within the audible spectrum. To configure the oscilloscope, two buttons are included to increase or decrease the timescale. A potentiometer is used to set the trigger level, and a button toggles the trigger on or off. The collected data is sent via USB serial to the computer, where a Python application is responsible for displaying the waveform. A multimeter will be connected to the generator's output signal in order to measure its frequency and compare results. Let's run some tests. Power up the breadboard, turn on the multimeter, and launch the Python application. Let's tweak the frequency a bit and adjust the timescale to improve the waveform display. Adjust the trigger level to catch the signal's peak. Now let's activate the trigger. Great! You can see that the waveform is now stable. Let's capture a snapshot of the signal to measure its frequency. By clicking on the graph, you can place a couple of reference points to determine the related time and frequency. We can see that the measurement matches the multimeter reading. Now let's try with another frequency and check the results. Once again, we see a match. Let's see how the circuit reacts when we increase the signal amplitude. When the amplitude is high enough, the protection kicks in at the saturation point. Now let's check how the oscilloscope behaves with a different waveform. Let's raise the frequency to higher values and adjust the timescale. Excellent. It looks promising. Thanks for your attention, and please remember to leave a like.